Bonjour. I would like to thank the organizers of the symposium for the invitation to present the third installment of the GEM program called GEM-GeoNorth. GEM-GeoNorth would allow for continuing collaborative geoscience research in northern Canada. From 2008 to 2020, Natural Resources Canada, NRCan, Geological Survey of Canada, the GSC, delivered the GEM program. At the time, Canada still had an insufficient understanding of the geology of vast tracts within its northern territory. Old data and old models often make for outdated conclusions. In collaboration with territories, provinces, and indigenous communities and organizations, the program included an extensive series of research projects which explored the structure and evolution of Canada's northern geology, including mineral and energy resource potential of the region. These studies, mostly led by NRCan scientists, include experts from leading Canadian and international research institutions, both in conducting fieldwork and subsequent laboratory analysis, data integration, and interpretation. GEM focused on characterizing the regional geological context, thereby providing frameworks to establish whether geological formations have a high or a low likelihood of resource potential. Governments and industry can use GEM knowledge, data, and maps to target their programs by focusing on areas with higher likelihood of research potentials. Likewise, northern communities and organizations can use GEM knowledge as part of their informed land use decision making. The new program will continue to enhance our geological understanding of Canada's north, focusing on areas with high potential for minerals and other mined commodities, as well as where development is likely to occur and benefit northern communities. GEM-GeoNorth will also conduct complementary geoscience research, such as the study of permafrost and the northern environment, to increase our understanding of the rapidly changing Arctic and northern landscapes and coasts, and how to address these changes. This complementary geoscience is relevant to assessing risk to northern infrastructure. GEM benefited from an active advisory group of Northerners, the AGN, representing the diversity of the Northern context. Membership is drawn from Indigenous socioeconomic development and governance organizations, the private sector, and territorial governance. The group provided key advice on building respectful and sustainable relationships with Indigenous and Northern peoples, communities, and organizations, as well as maximizing the uptake of GEM knowledge by Northerners. One of the first mandates will be to advise us on how we can co-develop research priorities with Indigenous governance organizations. GEM-GeoNorth is based on 5 strong pillars: to refine geological knowledge, to enhance our understanding of rapidly changing landscapes and coasts, to develop and provide new public geoscience to inform environmental assessments, to leverage innovative data-driven predictive methods to forecast cumulative impacts of the changing climate, and also to co-develop research priorities and products with Northerners and Indigenous peoples. Building on foundational geoscience from the first 2 phases of GEM, GEM-GeoNorth will develop new knowledge and tools useful to industry, governments, and northern communities. The impact of GEM research can be felt across many fields and sectors, including resource exploration, environmental studies, infrastructure, land use decisions, geoscience training opportunities and capacity buildings, improved research methods and models, technological and infrastructure developments, and in unexpected scientific discoveries. More than 2,000 maps and reports have increased publicly available geoscience information about Canada's north, including the identification of areas of high potential for critical minerals, such as gold, nickel, platinum group elements, rare metals, base metals, and diamonds. The data and knowledge collected by GEM activities are made available and accessible to the public at no cost. Now, let's investigate some of these successes. The Smoking Hills in the northwestern part of the Northwest Territory. There, fieldwork helped characterize the volcanoes for which the area is named. Slumping bedrock led to spontaneous combustion of pyrite-rich mudrock at numerous sites along the sea cliffs of Franklin Bay and inland along the Horton and Anderson River. The smoke is a combination of vapor and sulfuric acid gas. Fieldwork also led to the discovery that the Smoking Hills Formation bedrock is a source of natural acid-rich drainage. Streams and ponds in contact develop hyperacidic waters, some with a pH as low as -1.44, stronger than sulfuric acid. These waters also contain toxic concentration of many dissolved metals, including cadmium at 7,000 times recommended Canada's Safe Drinking Water guidelines. In July 2019, Fortune Minerals announced the discovery of a new copper mineralization potential at their gold, cobalt, bismuth, copper NICO project, building on GEM-1 collaborations and data from the Great Bear Region project. Renewed exploration at NICO stems from Fortune Minerals' new findings and from GEM and TGI, the Targeted Geoscience Initiative, research results. Instrumental to all that is GEM's geological and geophysical data and the program's collaboration with Fortune Minerals, which supplied researchers with large amount of geophysical data for modeling. The work we did at GEM Great Bear IOGCs is key to assess the natural metal content of rocks, both in till cover and rocks themselves, through the Great Bear Magmatic Zone, and information also important for environmental watershed studies. Superficial mapping of the Great Slave region and glacial sediment mapping in thaw-sensitive terrain identify extremely useful information for land use planning, infrastructure, and resource development. The Northwest Territory Department of Transport used GEM's superficial geological data to help plan the route from the Tlico All-Season Road, an estimated $400 million project. The road project, which avoids the thaw-sensitive terrain that affects the highway from Yellowknife to Big Cocoa, is now 70% completed and is planned to provide community access by the fall of 2021. This all-season road will also link the NICO project mentioned earlier to the rest of the world and increase the feasibility of opening a significant critical metal mine in Canada. From the Northwest Territories, we go to Nunavut. GEM discovered unique differences in bedrock underlying Boothia Peninsula and Somerset Island, indicating that mineral exploration strategies used in other ray areas are likely inappropriate for the Northwest Passage. GEM research provided relevant data and knowledge for the isolated region of Nunavut regarding resource assessment and economic development opportunities associated with potentially dramatic increases in shipping due to climate change impacts. South of the previous area, fieldwork in the Chantry-Talon area identified three main areas of economic potential in three different geological domains: newly recognized copper, nickel, platinum group elements, and massive sulfide, copper, zinc, gold, and silver resource potential. High-resolution satellite imagery integrated with information from over 14,000 field stations was used to produce new maps of glacial landscapes and surface materials west of Hudson Bay, synthesizing comprehensive historical and new GEM dataset in a critical area with known economic potential and planned transportation corridors between northern communities. GEM knowledge on uranium potential in the Kivalik region was taken into account when expanding a protected area. The Yuku-Sik-Salik National Park in Nunavut was expanded by 327 square kilometers in 2014 after an exchange of land between the Government of Canada and the Kivalik Inuit Association that was informed by results from the GEM program. The transfer resulted in the conservation of culturally and archaeologically significant land that will benefit all Inuit and Nunavummi. Through grants to communities and organizations, GEM helped incorporating cross-cultural interpretation of geoscience and promoting its application in land use and resource development decision-making. For the SATU geomapping initiative, GEM funded the acquisition and integration of several new GIS datasets into a cohesive atlas. For example, GEM research projects, archaeological data, community knowledge, resource interest, and exploration activities. Emphasis was on training users to technically navigate the atlas so that they can explore the information relative to their unique needs and at their own pace. As part of our engagement process, GEM held a geoscience field school at the community of Taluyok, Nunavut, in 2016. More than 160 community members of all ages took part of the geological field school, which took place over 5 days. The field school presented a unique opportunity for residents to learn more about the geological feature of their land, and it connected geoscience to local and traditional knowledge. Sometimes research can bring unexpected discovery. A routine sample collection led to a unique discovery in the evolution of life on Earth. Microfossils of fungi were revealed in samples of shale roughly 1 billion years ago from the Western Canadian Arctic, pushing back the earliest known occurrence of fungi on Earth by more than 500 million years. To note, the fossil is about half the width of a human hair. This discovery helps refine the evolutionary tree of complex organisms in the history of life on Earth. The story, published in the journal Nature, was picked up by major newspapers around the world, including the New York Times and The Guardian in England. Nationally, it was a front-page story in the Globe and Mail. While analyzing samples from sedimentary rocks of the region in Nunavut, researchers with the GSC made a rare discovery: the presence of a 7-centimeter thick bed of impact spherules, an indication of a large meteorite strike somewhere on Earth about 2.1 billion years ago. On Bylot Island in Nunavut, we found possible theropod dinosaur tracks. These were found in rocks that accumulated in a shallow marine lagoon along the coast of ancient Baffin Island about 100 million years ago. The high latitude location of the region at that time tell us that the dinosaurs and other life forms that lived there must have experienced long periods of darkness during the winter. Imagine what it must have been like for dinosaurs to be in the dark for 6 months of the year. One other very exciting find was an ancient marine reptile, which was also found in sedimentary rocks on the north side of Bylot Island. Pieces of bones from the paddle or the flippers of the marine reptile were brought back to the lab for identification and were determined to be from a plesiosaur. Plesiosaurs went extinct about 65 million years ago. This is the northernmost locality of Cretaceous plesiosaurs fossils in the world and likely the world's most northerly dinosaur tracks. GEM-GeoNorth will build on the success of GEM and continue the practice of sharing the knowledge and research findings to the involved communities and ensure that products are available, easily understood, and used in decision-making. The program will develop new knowledge and tools useful to governments, northern communities, and industry supporting mineral resource development and sustainable land use in the context of a changing climate. Our approach to strengthening the role of Northerners and Indigenous peoples in co-developing research priorities, knowledge products, and capacity building opportunities will potentially increase the program's effectiveness in addressing local concerns in earlier stages of the program delivery compared to previous phases of GEM. Next steps for GEM-GeoNorth include finalizing the co-development of research priorities between GEM-GeoNorth, territorial and provincial geological surveys, the AGN, Indigenous and Northern organizations, and industry associations. Discussions are underway with territories and provinces, and shortly with Indigenous groups to define research priorities of the renewed program. Call for proposals from Indigenous communities and organizations and academia will start around next spring, both aiming for capacity building and alignment with program objectives. Contingent on public health measures, the first GEM-GeoNorth fieldworks are targeted for summer 2021. NACAN will continue to engage with Northern and Indigenous communities before any fieldwork can proceed. I would like to thank you for the time you took to listen to the presentation. If you have any questions, please contact us to the links indicated on the slide. Have a great day. Bonjour.